All right, our Unit 1 test. If you had a version B, you'll find that the same parts of the test are available in your test as well. You'll just need to search for them. They won't be in the same order. Functions and relations, determining if each graph represents a function or not. Well, vertical line test is the best way to think about that. So, we check the vertical line test. We only hit one point all the way along, so this one is a yes, it is a function. But here, notice how a vertical line hits more than 1 point. This one would be a no. Vertical line, we're fine, uh-oh, right there would be a no. Now here it looks like we may not have a function, but an open circle means that point is not included, but it is down here. So we drew a line. We're not touching really there because it's not included. Even though we are here, it's okay. This is a yes. Now, on the next one, I do admit that the arrows didn't line up exactly the way I wanted them to. This one should have been going from the 5 to the 1. Both of these were supposed to go there and then go over here. It just turned out really bad. So I basically gave everybody a freebie on that one. But let's look at this one. Domain. What's the domain? That's all of your x values. And it says to write them in increasing order. So let's start with the smallest one. And since this is just a set of numbers, we use roster notation. So -2, 3, 4, 5, and 7. For the range, we look at our y values. And again, it's just a list of numbers. So we use roster notation. In increasing order, starts at -5, -1, 0, 3, 6, and 8. Now we look to see if it's a function or not. So we check to see that each x value is paired with only one y value. Uh-oh. -2 is paired with more than one y value. So no, it is not a function. Now, on to the graphical analysis. What is the domain of f of x? Now, domain are our x values. So we look, and I've mentioned this before, it's almost like the shadow. Where do the x values start? Let's go along here. They start here, and that's a solid point, so that point is included. And we still got x values. What I mean by that is if I was making a table of each of these points, I'd have x values all the way through here. And do you see how they just keep going? There's an arrow that means they keep going on forever. So this is a solid point, and then they keep going that way forever. So I could say, one way I could put that is that the x's are greater than or equal to -5. Or, oh, we love the interval notation. Interval notation says we start at -5 and include it, and then go off to infinity. Now, for the range, you're looking at your y values. So let's see, where do the y values start? Oh, that's the first point I have. And it is in solid, so it's included. And then we go up, and up, and up, and up, and off to infinity. So, for my range, all the y's greater than or equal to -4. In interval notation, that means we start at -4 and go off to infinity. For what values of x does f of x equal 0? Remember, f of x is just a fancy name for y. So what x values give me a y value of 0? Well, that would be here, -4, 2, and 6. -4, 2, and 6. What is the value of f of x when x is 0? So this is changing it around. What's y when x is 0? So here's when x is 0. The y value when x is 0 is 2.5 approximately. So that would be f of 0 would be approximately 2.5. Over what intervals is f of x greater than or equal to 0? Okay, now remember, f of x is the fancy names for y's. So down here, the y's are negative. Up here the y's are positive. Down here the y's are negative. Up here the y's are positive. So which ones are greater than or equal to 0? Greater than or equal to 0 means that we are positive. So the parts of the graph that are positive start here, go to here, start here, and then go on forever. So what x values make that part of the graph? Well, the x values that make this part start at -4 and go to 2. And since we are including the places where it is 0, that means we start at -4 and go to 2. And then we have a break, a gap. Remember, that means we're going to union two intervals. The next one starts up at 6 and goes on to infinity. Now, part 2, function operations. What we're doing is this is the value that's going to plug in for x. So f of -10. The absolute value of 3 times -10 minus 1 plus 5. That's -30 minus 1. That's -31 plus 5. Now we take the absolute value. The absolute value of -31 is 31 plus 5 is 36. Next one, h of -2. Now h is a piecewise function, so we need to see which piece -2 fits in. Is -2 less than 5 or greater than or equal to 5? Well, -2 is less than 5, so we look at this part. Oh, it's a constant. It means no matter what value we have that's less than 5, our output would just be 6. Now this one has 5. 5 is not less than 5. 5 is equal to 5. So this is what we do. It'd be 5 squared minus 10. That's 25 minus 10, which is 15. Next, composite function. That means I'm going to plug this value into g first. So I'm going to come off to the side, g of -1. G of -1, that's 4 times -1 plus 1. -4 plus 1, that's -3. Now that answer becomes the input for f. So now I'm going to try to find f of -3. Here's the function f. It says to take 3 times my input minus 1 and then add 5 at the end. So 3 times -3 is -9. Minus 1 is -10. Absolute value of -10 is +10. So end up with 15. Here we have another composite function. This time it says to send 2/3 into f first. So f of 2/3. F says to take the absolute value of 3 times the input minus 1, take the absolute value of all that, and then plus 5. 3 times 2/3 is 2. 2 minus 1 is 1. Absolute value of 1 is just 1. 1 plus 5 gives me 6. So now it's g of 6, because we take that answer and it becomes the input for the next function. G of 6. G says 4 times my input plus 1. 24 plus 1 is 25. G of 3 minus b. Now we look at g again. G is the function that says 4 times my input plus 1. Well, my input this time is this expression, 3 minus b. If I'm not careful, I wouldn't have looked up and noticed it says simplify each expression. So how do I simplify that? Oh, that's easy. Distribute. 12 minus 4b plus 1. Can add the 12 and the 1. That's 13 minus 4b. Or I could have wrote -4b plus 13. Commutative property says it doesn't matter what order they go in. G of t of x. Remember the O there really means g of t of x. So this one says we're actually going to take the whole function t, and it's going to become our input for g. So g is the function that says 4 times my input plus 1. This time I'm going to plug in all of t of x, or substitute it in. So x squared minus 2x. Distribute 4x squared minus 8x plus 1. Now what if we go the other way? It says to place g of x inside of t. So g of x was 4x plus 1. Now I have to look very carefully. T has 2 places to put the input. So the first part says to take the input and square it minus 2 times the input. Now here's where it's going to be problems when we're simplifying this. People forget that something squared really means multiply it by itself. So 4x times 4x is going to give me 16x squared. I'd have 4x times 1, which is 4x, plus 4x. That's 8x plus 1. And now distribute the negative 2. Negative 2 times 4x is negative 8x. Negative 2 times 1 is negative 2. So I end up with 16x squared minus 1. Now, to continue those types of things, but with different functions, the next part we have new functions. G plus f. That literally means to take g of x, which is x squared minus 5x plus 2, and add to that f of x. F of x is 3 minus 2x. Now I want to add those together. So you just combine your like terms. There's no other x squared. I have negative 5x and a negative 2x. That gives me negative 7x. Then I have a 2 and a 3. Gives me a 5. Now here, literally, says to take 3 times f of x minus g of x minus all of g of x. Oh, I almost forgot. Some people were having problems with this right here. All that tells me, just like down here, it tells me what my input value is. For these problems, it's telling me that I only have an x. What it really means is that we have g of x plus f of x. It is not multiplication. Just want to make sure that was clear. All right, 3 times 3 minus 2x would give me 9 minus 6x. And if I'm subtracting all of this, that means I'm subtracting the x squared. I'm subtracting a negative 5x, which would give me plus 5x. And then I'm subtracting the 2. Combine your like terms. We have negative x squared. Negative 6x plus 5x is going to give me a negative x. And then 9 and a negative 2 would give me a 7. The next one. And I'm going to change colors so we can tell the difference in the problems. This literally means I'm going to take f and use x as my input times g, still using x as my input. This is just saying that both of them are just using x as their input. They could have told us a specific number, but they didn't. It just means we're leaving x in as the variable. It does not mean to multiply by x. F of x is 3 minus 2x. G of x is x squared minus 5x plus 2. Now all we have to do is distribute. Now if you have problems and get lost in your work, you can use a box to help keep track of it. Here's 3 minus 2x, and the other one is x squared minus 5x plus 2. 3 times x squared, so we're just distributing the 3 to each of these 3 terms. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x. And 3 times 2 is 6. Negative 2x times x squared gives me a negative 2x cubed. Negative 2x times a negative 5x gives me a positive 10x. All right, I was recording this video and it stopped kind of part of the way through. So here's where I multiplied the two functions in the box, and now I can combine my like terms as I take it out. I've got negative 2x cubed. I've got 10x squared and 3x squared, so that's 13x squared. I have negative 15x and negative 4x. That gives me a negative 19x. And then I have a plus 6. That's all you're doing is distributing twice. You send the 3 through, and then you send the negative 2x through. Now, f of g of x. F of g of x. Remember the O just means of. F of g of x means I'm going to take f of x, which is 3 minus 2 times my input, and g of x becomes my input. G of x is the function that says x squared minus 5x plus 2. So all I really have to do is distribute and simplify. So that gives me 3 minus 2x squared plus 10x, and then that's a minus 4. Now I'll just combine like terms, negative 2x squared plus 10x minus 1. All right, the last one, tricky. H of x squared means I'm going to take h of x and square it, which means to multiply it by itself. 3x times 3x is 9x squared. Negative 15x and another negative 15x is going to be negative 30x. And then negative 5 times negative 5 is 25. Now, our next section is about inverse functions. Inverse functions undo each other. They're also where the domain and range are switched. So the test to see if they're inverses or not is you would take f of g of x and also look at g of f of x. If they undo each other, we should just get x back. So f is the function 2 times my input plus 3. If I plug in g of x is negative 3x minus 2. 2 times negative 3x is negative 6x minus 4 plus 3. Is that going to give me an x back? That's a no. And guess what? If it didn't pass that one, it doesn't matter if it passes this one. So this is not inverses. Let's try the next one. We're going to take f of g of x and then g of f of x. Now, do you wonder why it says x has got to be greater than or equal to 0 here? Look at that. Remember square roots? Anything under a square root cannot be negative. Okay, f of x was the function 1/3 my input squared. My input this time is the square root of 3x. What happens when you square a square root? They undo each other. So out would come out just 3x. 1/3 of 3x is just x. Ooh, we're looking good so far. Let's see if it works the same way if we swap them. G is the function, the square root of 3 times my input. F is 1/3 x squared. So 3 times 1/3 would just give me 1 x squared. Square root of x squared would just give me x. Oh, yes! They are inverses. Now, if you remember back on how the relationship between the domain and range, or how the x's and y's work, the domain and range are switched. So remember, to find the inverse, you will literally switch your x and y. I don't have a y, but I know f of x is just another name for y. So to find the inverse, switch x and y. If I switch the x and y, I get x equals 3y minus 7. And then remember, we need to solve for y. So let me add the 7 and get x plus 7 equals 3y. Divide by 3, y equals, and I could leave it as x plus 7 divided by 3, or make it prettier, 1/3 x plus 7/3. Now, do you remember there was notation for the inverse of f? The inverse of f is f to the negative 1, still using variable x. So now I tell people what the inverse of f is. All right, part 4, linear functions. How could we tell if lines are parallel, perpendicular, or neither? The way to tell whether they're parallel, perpendicular, or neither is to look at their slopes. The slope of line 1. Line 1. 12 minus 7, because remember it's the difference of my y's over the difference of my x's. 12 minus 7 gives me 5. 5 minus 3 gives me 2. Now, let's look at line 2. 10 minus 8 over 6 minus 1. 10 minus 8 is 2. 6 minus 1 is 5. Now, for parallel, they'd have to be the same. They're not. Perpendicular, wasn't that negative reciprocals? Are those negative reciprocals? They're reciprocals, but they're not opposite signs. So this is neither. All right, so negative reciprocals. All right, so the next one, find the equation of the line that passes through the point 12, 6 and is perpendicular to the line y equals 4x minus 25. If it's perpendicular to that line, then its slope is going to be the negative reciprocal of 4. That means it's negative 1/4. I'm going to use point slope form because I like it. That's where you take y minus your y value equals the slope times x minus the x value. And you're done. Now in the next problem, we're trying to find a line that is parallel to x minus 3y equals 6. Oh, I don't know what the slope is. Oh, I can solve for y. That'll give me negative 3y equals negative x plus 6. Divide by negative 3. Negative 1 divided by negative 3 is 1/3. 6 divided by negative 3 is negative 2. So the slope of this line is 1/3. If I'm parallel, then my slope is also 1/3. So, point slope would be y minus my y value equals the slope times x minus the x value. All right. Perpendicular to x equals 2. Well, x equals 2 is a vertical line. So I need a horizontal. Now, horizontal lines are y equals. So I need to know a y value, any y values on that line, because they all have the same y value. If it's passing through that point, then that's my y value. It's 5. All right. Next, absolute value equations and inequalities. And the notations, and this should have been the easy part. Graph the interval, bracket, -4 to 1. All right, so let's go ahead and do that part. Bracket means we include it, so that gets a dot at -4. 1 has a parenthesis, so it gets an open circle. And we want the interval between those. Now, union means we got a little bit of a gap. Then the next part starts at 2.5, and it's got a bracket, so that's going to be a solid dot, comma, positive infinity. So it keeps going off and off and off and off. All right, the next one. It's got an open circle at -6. That means it's got a parenthesis at -6 and a closed circle at 7. That means, I switched them. Interval notation would be -6, 7. The inequality, one way you could do is a compound. -6 is less than x, which is less than or equal to 7. Less than or equal to because we have a solid dot there. You could have also said x is greater than negative 6 and x is less than or equal to 7. When it's combined like this, it's an and. It's a gap. It's an or. So let's go ahead and do the inequality version so I'm doing the right way. We're to the left, closed circle. That means x is less than or equal to negative 2. 4 and out, that's x is greater than 4. Interval notation. We start from the left, negative infinity to negative 2, including negative 2. Gap. Start back over at 4, not including 4, and go up to positive infinity. Solving absolute value equations and inequalities. The first thing you should always do is isolate the absolute value. So when I isolate the absolute value, the first thing I'm going to do is add 3 to both sides, and the right side would become 20. I'm going to go ahead and divide by the 5. That gives me absolute value x minus 3 equals 4. Now, I'm going to have the positive version, which is that x minus 3 equals 4. The negative version is that the opposite of x minus 3 equals 4, or x minus 3 equals negative 4. If x minus 3 equals 4, add 3 to the other side, I get x equals 7. If it's x minus 3 equals negative 4, when I add 3, I get x equals negative 1. Graphing that on a number line gives me the point negative 1 and the point 7. Next one, isolate the absolute value before you ever start. So add 6 to the other side. Absolute value of 3 minus 2x is greater than 11. The positive version is that 3 minus 2x is greater than 11. The negative version is the opposite of 3 minus 2x is greater than 11. It does not change yet. Be careful with that. Okay, so here I would subtract the 3. I get negative 2x is greater than 8. Divide by negative 2. When I divide by a negative number, my symbol flips. 8 divided by negative 2 gives me a negative 4. Now over here, since I noticed that I had a negative coefficient of x here, I'm thinking I might just go ahead and distribute that negative on this right side and see what happens. I get negative 3 plus 2x is greater than 11. Ooh, this is looking better already. Add 3 to the other side. I get 2x is greater than 14. That says that x is greater than 7. Remember, a greater than should give me a gap. Let's see if we get it. Here's negative 4. Less than negative 4 would be this way. 7 greater than would be this way. Great. Next one. Get the absolute value by itself. So I'm going to divide both sides by 3. Absolute value of 1/2 x minus 1 is less than or equal to 4. Split it up. Got the positive version, 1/2 x minus 1 is less than or equal to 4. The negative version is that the opposite of 1/2 x minus 1 is less than or equal to 4. I'm going to add 1 to the other side and get 1/2 of x is less than or equal to 5. How do I undo 1/2 in front? Well, multiply both sides by 2. That gives me x is less than or equal to 10. Ooh, I think I'm going to divide both sides by negative 1 and get rid of that negative sign this time. Now when I do that, this becomes a negative 4, and my symbol does flip. Now I'm going to add the 1, and that becomes a negative 3. To undo half of x, I multiply both sides by 2, and I get x is greater than or equal to negative 6. And since this started as a less than or equal to, I agree. It should be a sandwich between negative 6 and 10. Done. Next problem. Isolate the absolute value first. 6 minus 1/3 x. Subtract the 12, and I get this is less than negative 4. Divide by 2. Can an absolute value be less than a negative number? absolute values are always positive. There is no way you can do this. This would be no solution. All right, now we move on to the final part, graphing functions. Let's remember what this graph is. Absolute value functions. What do they look like? Well, this is a V shape. The x minus 3, when you subtract 3 from x, that moves it right 3. The minus 4 at the end moves it down 4. The 2 in front tells me that I have a slope of 2 on the right side and negative 2 on the left side. So I go right 3, down 4, slope of 2, up 2 over 1. And this is going to be a mirror image on the other side. There we go. Now we're going to use that picture to solve these following equations. We have f of x equals 0. What values make f of x, or y, equal 0? Well, y equals 0 right here and right here. So the values of x that do that are 1 and 5. Which values make f of x less than or equal to 0? Well, the part of the graph where the y values are negative is down here. This is the negative areas for y. These are positive values for y. So what x values create that part of the graph? Well, that would be between 1 and 5. Oh, and including them. Now, what values of x make f of x greater than 0? In other words, which make these positive pieces? Well, it doesn't say or equal to, so we start at negative infinity and we go up to the 1, but this time we're not going to include it. We're only wanting this piece, this little ray right here. Then the other ray would be from 5 to positive infinity. Now, we have a piecewise function here. So we need to be very careful when we're graphing it. Let's take the first piece. X, absolute value of x plus 7 minus 2. Remember, x plus 7, when you add 7 to the x, that means we move left 7. Minus 2 is down 2. Slope is 1. So this side is up 1 over 1. Now, look at the boundaries here. It's going to go up and up and up. Do you see where x is negative 3? That's where I'm going to stop it. Because it says that's as far as we're going to go on the right. Now on the left, we're going to go up to negative 10. So let's see where we're at when we get x is negative 10. Now, are you including that point? Yes. So we're equal to. Now go to the next piece. I'm going to do the next piece in a different color. The next piece is just 2. That means y equals 2. It's just a vertical line. It starts at negative 3 and goes up to 1. Easy. The next one. Now I may need a pencil to start this one because it says the y-intercept is 8. Slope is negative 3. So down 3 over 1, down 3 over 1. Okay, so this is the way the graph goes. Now, do I want all of it? No, it says I only want to start that one where x is greater than or equal to 1. Here's where x is equal to 1. So greater than would be all of these. And it would keep going forever because it said greater than 1. Now, let's see if we need to use the graph, if we can, to solve some of these. F of negative 7. When x is negative 7, our y value is negative 2. Negative 2.65, oh, that's a 2. F of 1. Now, watch out. It's an open circle there. My answer has got to be 5. Uh-oh, 5/3. I can't tell that on the graph. Oh, but 5/3 is bigger than 1. I could plug that in there. It's negative 3 times 5/3 plus 8. Negative 3 times 5/3 is going to give me a negative 5 plus 8, which is going to give me a 3. What about f of 50? Well, that's definitely bigger than 1. So negative 3 times 50 and then plus 8. That's negative 150 plus 8, negative 142. Last problem, because I'm not doing the bonuses for you. The last problem, look at each of these. These are just horizontal lines. This is the horizontal line of y equals negative 3. Now it says it's only for when x is less than negative 6. So it goes up to where x is negative 6 and it has an open circle. Now, at negative 6 we're going to move up and do the y value of negative 1, which would be here. We're going to go all the way up to when x is negative 3, and that's not equal to, so we have an open circle again. Now we go up to where y is 0, solid, because it's underlined, and go all the way up to 2, and it says, ooh, we're going to include 2. So I need to have a solid circle there. Now we're going to draw the line y equals 2, starting when x is 2, all the way up to 3. It's a short line. Now we're doing the line y equals 5 from 3 up to 5, not included, open circle. Now I'm doing the line y equals 7 from 5 up to 9 and not including. What kind of graph is that? Well, it is a piecewise, but it's also a step function. I accepted either answer.